Question number 3. Find the parametric form of vector equation and Cartesian equation of a plane. Through, how many points are given? 2. Plane through the 2 points. Immediately call them x1, y1, z1, x2, y2, z2. This is A vector and this is B vector. Parallel to the line joining these two. So parallel implies direction. Direction implies difference of the 2 points. Let us remember, whenever they give you points, difference of the points is nothing but direction. So subtract the points. So direction I call C vector. Subtract it. 2i plus j minus 3k minus I plus 5j minus 8k. It is only a parallel vector. You can subtract from first point to the second point or 2 minus 1. Anything is correct only since we deal with only direction. 2i plus j minus 3k. Take the minus sign inside. Plus I minus 5j plus 8k. Simplify the answer. C vector is 2i plus I, 3i. J minus 5j minus 4j. Minus 3k plus 8k, 5k. So we know the parallel vector. So this is parallel. Let us remember. The points. What is A vector? 2i plus 2j plus 1k. And what is B vector? I minus 2j plus 3k. And these two are points. So I know the points and I know the parallel vector. What is my next step? Writing parametric form of vector equation. What is parametric form of vector equation? R vector equals to, how many points are given? 2. So first time A vector S into B minus A plus T into C vector. Let me find out what is B minus A. Just subtract B vector I minus 2j plus 3k minus A vector 2i plus 2j plus k. As I subtract, I minus 2i minus I minus 2j minus 2j minus 4j, 3k minus k is 2k. Or you can do with steps like this, or you can do directly. It's up to your speed. Now I know everything. Let me substitute in R vector. So what is R vector? A vector is 2i plus 2j plus k plus S into B minus A minus I minus 4j plus 2k plus T into C vector 3i minus 4j plus 5k. This we call as the vector equation. Cartesian equation, let us remember the formula. It is similar to the second problem. Determinant, let us substitute x minus x1, 2, 2, 1, x1, y1, z1, x minus 2, y minus 2, z minus 1. x2 minus x1 only, b minus a vector, which we have found out here. So write the numbers minus 1, minus 4, 2. C1, C2, C3 are these numbers. C1, C2, C3. So I get 3 minus 4, 5, which is equal to 0. Expand the determinant. X minus 2 into, hide the row and column, minus 20 plus 8. Minus y minus 2 into, again hide the row column, minus 5 minus 6. Plus z minus 1 into, hide the row and column, 4 plus 12 equals to 0. Let us expand this. X minus 2 into minus 12. Take minus in, plus minus y plus 2 into minus 11 plus z minus 1 into 16 equal to 0. Expanding, minus 12x plus 24 plus 11y minus 22 plus 16z minus 16 equals to 0. Rewriting the equation, minus 12x plus 11y plus 16z, 24 minus 22, 2 minus 16 minus 14 equal to 0. We always keep x to be positive. So the answer is 12x minus 11y minus 16z plus 14 equal to 0, and that is the Cartesian equation. Question number 4. Find the non-parametric form of vector equation and Cartesian equation of a plane through. So this we call a vector perpendicular to the plane. So this will give me direction. Parallel to the line. So this will again give me direction. So let me write this as A vector, this as B vector, and this as C vector. As we read the problem, let us identify point and direction separately. Through tells it is a point. Perpendicular, parallel, these words will tell me perpendicular to the plane tells me it's a direction. Parallel to the line also tells me it's a direction. So let me write out everything properly. A vector equals I minus 2j plus 4k. And B vector, it is the direction. Instead of x, y, z, remember to put I, j, k. I plus 2j minus 3k. And C vector equals, the denominator tells me the direction in case of line in Cartesian form. So 3i minus j plus k. Once I know the three things, this is a point, write x1, y1, z1. It is 1 minus 2, 4. This is a direction, write b1, b2, b3. It is 1, 2, minus 3. And this is also a direction, so call C1, C2, C3. Let us remember these things properly. Points we take x, y, z. First point x1, y1, z1. Second point x2, y2, z2. Third point x3, y3, z3. Directions we take b1, b2, b3, c1, c2, c3. So I get 3 minus 1, 1. Now let us remember to write that non-parametric. So before going into that, what is the formula? Non-parametric form of vector equation. We write it as r minus a vector dot direction b, another direction c cross equal to 0. So we get b cross c. I have to find out. What is b cross c vector? We write I, j, k. B vector components 1, 2, minus 3. C vector 3, minus 1, 1. Let us expand it. 2 minus 3 minus I. 1 plus 9, 10j, but j is negative, k. Minus 1, minus 6, minus 7k. Once I know b cross c, let me substitute here. R vector minus, what is a vector? I minus 2j plus 4k. Dot b cross c. B is I plus 2j minus 3k cross c vector is 3i minus j plus k equals to 0. Since we have found out b cross c, let us substitute. It is r minus I minus 2j plus 4k dot minus I minus 10j minus 7k equals to 0. Remember, every time we must put equals to 0. Now r dot this vector minus I minus 10j minus 7k minus this 2 I have to do. So I am doing distributive property. R dot the vector minus this vector dot. So I get I minus 2j plus 4k dot minus I minus 10j minus 7k equals to 0. R dot minus I minus 10j minus 7k minus, how do we perform the dot product? I and I, 1 into minus 1, j and j, minus 2 into minus 10, it is plus 20, k and k, minus 28 is equal to 0. Simplify the answer. It is r dot minus I minus 10j minus 7k minus, this is minus 9, already 1 minus, so plus 9 equal to 0. So this is the non-parametric vector equation form. Now since everything is minus, I can also remove the minus symbol and cancel here. So my answer can also be rewritten as r dot, changing the symbol to be positive, I plus 10j plus 7k. This would become minus 9. Taking to the other side, it is equals to 9. Now we need to write the Cartesian form. For Cartesian form, put r vector equals xi plus yj plus zk. Dot implies I and I, j and j, k and k. So what is the Cartesian format? I becomes x plus 10y plus 7z. So these two we find the dot product equals to 9, or bring 9 to the left, x plus 10y plus 7z minus 9 equals to 0, and that is the Cartesian equation. Question number 5. Find the parametric form of vector equation and Cartesian equation of a plane containing the line. Underline this. Remember, it's a very important thing. See, we have a plane like this, and it's containing a line implies the line direction I need and the line's point also I need. The point on the line is on the plane. The line's direction is for the plane. So I have to take this as a point, remember, and t into what tells me the direction. So whenever they give you parallel to the line, I take only the direction. Whenever they give you containing the line, let us remember I should take the point on the line as well as the direction. So this we call A vector and this we call B vector, but this is point and this is direction. Perpendicular to a plane. The word perpendicular to a plane tells me this is my parallel direction, say C. Line, they will say either parallel or containing. Parallel tells me take only the direction. Containing, the word tells me take the point as well as the direction. And whenever they give you perpendicular to the plane, consider the normal of the plane as the next direction, that is C vector. Now let us write out all that is given to us. So point, let me call A vector, that is I minus j plus 3k, and direction B vector equal to 2i minus j plus 4k, and again the direction C vector equals to I plus 2j plus k. Having known A, B, C, we need to write the parametric form of vector equation. So parametric form of vector equation, the formula goes R vector equals A vector S into B vector T into C vector. Remember, this must be point. These two should be directions. With S and T, only directions will come. Now rewriting the answer. R vector is equal to A vector I minus j plus 3k plus S into B vector 2i minus j plus 4k plus T into I plus 2j plus k. This we call as the parametric form of vector equation. Where S, T are scalars. Now we go on to the Cartesian form. Cartesian form is, remember, it is having a single point, x minus x1, y minus y1, z minus z1. Second row, I have to write the directions. It is B vector, so I will write B1, B2, B3. The next direction is C vector, C1, C2, C3 equals to 0. Let us substitute. Determinant x minus 1, y minus of minus 1. So it is plus 1, z minus 3. B1, B2, B3 we write from here. 2 minus 1, 4. C vector 1, 2, 1 equals to 0. Expanding this, it is x minus 1 into, hide the row and column, minus 1 minus 8 minus y plus 1 into, hide the row and column, 2 minus 4 plus z minus 3 into, hide the row and column, 4 plus 1 equals to 0. Simplifying the step, x minus 1 into minus 9. Minus we take it in. So remember, plus minus y minus 1 into minus 2 plus z minus 3 into 4 plus 1, that is 5 equal to 0. Multiplying minus 9 into x, minus into minus plus 9 plus 2y plus 2 plus 5z minus 15 equal to 0. Simplifying the answer, minus 9x plus 2y plus 5z. Simplifying these numbers, 11 minus 15, that is minus 4 equal to 0. We try to keep x to be positive. So the answer is 9x minus 2y minus 5z plus 4 equals to 0. So parametric form, we write R vector equals A plus SB plus TC. Where these S and T, I can also write they belong to R, real numbers, scalars which are real. Cartesian, remember the very important thing, equal to 0 in every line. So the equation when you write, it should be equated to something. Here we have written R vector equal to. And another important thing is containing the line. Whenever the plane contains the line, take the point as well as the direction. So remember to use these techniques in the next problems. Sixth question, find the parametric, non-parametric Cartesian equations of a plane. Through three non-collinear points, 3, 6, minus 2, minus 1, minus 2, 6, 6, minus 4, minus 2. Notice the word non-collinear. The points should not be in the same line. Then they will describe only a line. If they are like this only, I can create a plane passing through the 3 points. So always they give 3 points. They have to mention they should be non-collinear to proceed with. Take the points as A vector, B vector, C vector, and all are points only. x1, y1, z1, x2, y2, z2, x3, y3, z3. Let us write in detail. A vector equals, putting I, j, k for the point, 3i plus 6j minus 2k. B vector equals minus I minus 2j plus 6k. And C vector equals 6i minus 4j minus 2k. Having known the 3 points, my main question is to find the direction. So how to find out the direction? This point let me keep as it is. So to find out the direction, I must find out B vector minus A vector, also C vector minus A vector. So let us subtract B vector minus A vector. Minus I minus 2j plus 6k minus A vector is 3i plus 6j minus 2k. As I subtract, minus I minus 3i minus 4i minus 2j minus 6j minus 8j, 6k minus of minus is plus, 6k plus 2k is 8k. C minus A, 6i minus 4j minus 2k. Minus, I can also change the symbol and write minus 3i minus 6j plus 2k. Either you put minus and bracket or you change the symbol minus minus plus. This will be easy for me to do. 6i minus 3i, 3i minus 4j minus 6j minus 10j minus 2k minus plus 2k will be 0k. So we have 6i minus 3i, 3i minus 4j minus 6j is minus 10j. K gets cancelled. Having known A, B minus A and C minus A, what is the vector equations? Parametric, non-parametric. First let me write the parametric form of vector equation. R vector equals A plus S into B minus A plus T into C minus A. R vector equals A vector 3i plus 6j minus 2k plus S into B minus A minus 4i minus 8j plus 8k plus T into 3i minus 10j. So this is the parametric form of vector equation. Next I have to write the non-parametric. So what is the non-parametric form? We remember the formula. It is dot and cross. So non-parametric form of vector equation is R minus A dot B minus A cross C minus A equals to 0. So first I have to perform what is B minus A cross C minus A. Remember, we put determinant ijk. B minus A as we found here, minus 4 minus 8, 8. C minus A is 3 minus 10, 0. Expand the determinant and find the answer. As we find B minus A cross C minus A and simplify, we have this vector which we will substitute. R vector minus, what is A vector? 3i plus 6j minus 2k dot B minus A cross C minus A. It is minus 4i minus 8j plus 8k cross, what is C minus A? 3i minus 10j equals to 0. This answer as we found, let us substitute. R minus 3i plus 6j minus 2k dot 8 into 10i plus 3j plus 8k equals to 0. 8 I can bring it down. 0 by 8 is 0. So forget it. Dot product is only between the vectors. So I write r dot the vector minus the two vectors dot. So how do you write it? R dot 10i plus 3j plus 8k minus 3i plus 6j minus 2k dot 10i plus 3j plus 8k. 0 by 8, I will simply write 0. This is again r dot 10i plus 3j plus 8k minus, we'll do I and I 30, j and j 18, k and k minus 16 equal to 0. Or we arrive at r dot 10i plus 3j plus 8k minus 30 plus 18, 48 minus 16 is 32 equals to 0. So this is my non-parametric form of vector equation. How to proceed with the Cartesian form? From here, I can write directly the Cartesian form replacing ijk by xyz. 10x plus 3y plus 8z minus 32 equals to 0, and that is the answer. Remember, this is B cross C. So Cartesian form will contain x, y, z and a constant. Question number 7. Find the non-parametric form of vector equation and Cartesian equation of the plane. See, usually a line, a direction or a point like that were given. But now they have given the parametric form. So this is actually the parametric form. From the parametric form, we need to find the non-parametric and Cartesian. Now S into, so tells me this is direction B vector. T into tells me this is direction C vector. And R equals to tells me this is point, and I call it as A vector. So let us write down A vector equals 6i minus j plus k. B vector equals minus I plus 2j plus k. And C vector equals minus 5i minus 4j minus 5k. How do you find out the non-parametric form? So non-parametric form, we write dot and cross. R minus A dot B vector cross C vector equal to 0. I need to find out what is B cross C. Determinant, first row I, j, k. Second row B vectors minus 1, 2, 1. C vector minus 5, minus 4, minus 5. Let me expand and get the answer. Minus 10 plus 4 minus j into 5 plus 5 plus k into 4 plus 10. Simplifying, minus 6i minus 10j plus 14k. As I get B cross C, let me go on substituting in this. R vector minus A vector is 6i minus j plus k dot B cross C minus I plus 2j plus k cross minus 5i minus 4j minus 5k equals to 0. Remember to put equals to 0. This becomes R vector minus 6i minus j plus k dot, this answer we have performed here. It is minus 6i minus 10j plus 14k. I can actually take minus 2 common out. R minus 6i minus j plus k dot, take minus 2 out. It is 3i plus 5j minus 7k equals to 0. 0 by minus 2 is 0. So forget this number. dot product with this. So r dot this vector dot this. So how do I write it? R dot 3i plus 5j minus 7k minus 6i minus j plus k dot product with 3i plus 5j minus 7k equals to 0. Finding the dot product, first term we write as it is 3i 5j minus 7k minus, remember the dot product, I and I 18, j and j minus 5, k and k minus 7 equals to 0. This implies r dot 3i plus 5j minus 7k. 18 minus 12 is 6. So minus 6 equals to 0. Now I need to write the Cartesian form. Remember, for Cartesian form, r vector equals xi plus yj plus zk. As I substitute, dot product tells me I and I, j and j, k and k. So as I multiply, it is 3x plus 5y minus 7z minus 6 equals to 0. So we have just written the non-parametric form of the vector equation and the Cartesian form given a parametric form of a vector equation of a plane.